in this video, I wanted to work on setting up the foundation for a cell shading post-process material. So if you look at what I have in the screen right now, in my level, this is what the expected outcome should look like. So I have my post-process volume selected. Let me take a look, show you that real quick. So if you go to the post-process volume and scroll down, down, right here. So under post-process materials, you'll have an array of materials that you can apply to your post-process volume. So I have one applied right now, and I have this set to 1. So let's change this to a 0, just so you can show what the scene looks like without the material applied. So this is the standard lighting, how the scene would look without any post-process effects on it. And then if we set that back to 1, this is what we should get. So if you notice, we have kind of two different bands, right? So we have our light area and then the dark shadow area. So the idea is the idea with cell shading, or toon shading is another term for it. The idea is to kind of imitate a hand-drawn art, right? So we're trying to get a cartoon look. So let's go ahead and get started and see how we can set up at least some of the basic aspects of a cell shader. So first things first, let's go to our content browser, and then we'll go to material, create a new material, and let's call this m_cell shading. I'll call it vid_pp for post-processing. And then let's open that up. Okay. All right, so first things first, our main material node is selected by default when you create a new material. If you look on the left-hand side, we have our details. And so the first thing we want to do is look at our material domain, blend mode, and shading model. Just as a rule of thumb, when you're creating a new material, you want to take a look at these 3 settings. And of course, there's other important settings in here, but this is probably where you should start if you have an idea on what type of material you're making. So in this case, we're going to just change the material domain. So right now it's set to surface. We want it to be post-process. So we'll change that to post-process. And then we see that all of the input pins or the outputs for this material are now grayed out, and all we have is a emissive color. So everything we do, everything we add, will add up and just be plugged directly into our emissive color, and that'll produce the results we're looking for. So, all right, so let's first start by looking at what we need to accomplish to get the foundation for this effect. So when you're working with cell shading, what we want to do is look at the scene, the lighting in the scene, or the colors in the scene, look at how bright they are in each area, and then we want to determine how to handle it based on if this area is really light or really dark. So the question is, how do we sample the scenes to get an idea on what the colors look like within each frame, right? So first things first, let's right click. We're going to search for scene texture. And that'll give us this scene texture node. And by default, it has scene color. Let's click the little drop down and let's change this to, we want post-process input 0. Let's start with that. And then I'm gonna build out a couple of nodes here, and then we'll talk about what exactly this scene texture node is doing, and so what this starting logic is really trying to accomplish. So first, let's drag off of our color. Let's search for desaturate. I want this desaturation node. So that'll basically give us grayscale, a grayscale effect, right? And we'll click D, which will give us the divide node. And we'll plug that in. Oops, I'll plug that in. There we go. Okay. And then we'll right click, we'll search for saturate. Okay. And then if you eye and click down your mouse, you'll get an if node, and that'll handle our logic and tell us how we want to handle the two different effects, right? The light area versus the dark area in our scene. Okay. And then I'm going to drag this over just a little bit. The last thing I want to do, well, the last thing for this kind of first set of logic, we're going to drag off, and then we're going to search for, what is it? Named reroute declaration node. And we're just going to call this lighting, or lighting buffer would be fine too. I'm just going to put lighting. Okay. All right. So what else do we need to do? So we need something to happen here, right? We need to divide by something. So let's just copy our scene texture, drop that down here. And then we'll drag off a color, and we'll search for max. Let's set this to 0.05. So this will give us the max value between 0.05 and whatever is coming out of our color here for this scene texture. And let's actually change this value. So this one we want to set to diffuse color is what we want. There we go. Okay. And then we'll take another desaturation. So I'll just duplicate this one. We'll plug that in here. And we'll divide that by there. Okay. All right. So a few other things we need to connect, right? So we need to add some additional logic into our if node here. So for B, let's just put a constant value for now. So we'll do 1 and click, and we'll set this to 0.5. Like so. And then we'll take our diffuse color, and we're going to just duplicate that 2 times. Drag that over there. And then we need 2 multiply nodes. And we're just going to plug these into our colors output here. Oops. Try to make our lines as straight and clean as possible. Okay. And so this first one we're going to plug into A is greater than B. Second one, and it goes into A is less than B. And then the A is equal to B will just default to A is greater than B if there's nothing plugged in there. So these will be handled the same. That should be fine for starting out. Okay. So let's set, what we're going to do is, I'm going to leave those multiplies set to 1. We'll talk about what's going on here, and then we can then look at what those values need to be. So the scene texture node here, essentially what it lets us do is sample data from various render targets or scene buffers. So what we can do is, within this material, we can look at what has already been generated or rendered on the screen. So for this post-process input, for example, what this means, post-process input 0, that essentially means, and let's go back over here real quick. So we have this this array of post-process materials. So that array, or that post-process input, is looking at these post-process materials that we're applying to this volume. And so what we're doing by looking at this scene texture ID is basically telling the material to look at what's on screen before any of the post-process changes have been applied. So what we get with this input 0 is essentially the final image before any post-process logic or data has been applied to the image. So before any modifications. So we get the final image essentially. And then with this diffuse color, this is just looking at or sampling the color of each pixel within the scene. And so we get information about the pixel, and then we can use that information to make comparisons, or to really just get to identify what that color looks like or what it's doing within that frame. So with that in mind, we have a desaturation node. So we're desaturating both of these inputs. And so the desaturation, let's add a comment here just so we can get a better idea. I'll add, let's start with the comment here. So this is just going to give us our grayscale value. So actually, let's just convert to grayscale is what we're doing here. Okay. And then I'll drag this out just a little bit. Okay. So we're going to divide these values. We're just looking at the grayscale, so we just desaturate the color coming from the pixel. And then this saturate node, it's kind of confusing or misleading because we have desaturation and then saturate, but they're doing different things. So if you search for clamp, so clamp is pretty commonly used. So what we're trying to do with clamp is we're keeping our input value between a specific range. And so with clamp, you can set your min and max to any values. So it doesn't have to be 0 and 1. We could set this to 5 and 10 if we wanted to, for example, or 100. So between 5 and 100, our value is going to be clamped between that. On the other hand, with saturate, we are essentially, this is specific or dedicated to clamping a value between 0 and 1. And the nice thing about this node is that it has, if you read the tooltip there, has essentially 0 cost for modern graphics cards. So if you know your value needs to be clamped between 0 and 1, use the saturate as opposed to just the clamp. All right, so we're going to clamp our values between 0 and 1, and that allows us to have a threshold, right, between where we want to determine what areas are shadows or dark areas versus lit and or bright areas. And so we're just going to split it right in half. We're going to use 0.5. And then down here, so we're going to, with this logic, we're just going to look at the diffuse color. And so this basically gives us the flat look that we're expecting with the cell shader. So we're using just the default input color, and then we are multiplying this by a value. What this multiply is going to do is pretty much just going to allow us to tune the value, tune the input. So I'll show in a bit, but we're going to parameterize these. So I'm going to just do S and click, and then let's just call this brightness. This might be a little weird. I'm just going to call it something like that, and then so we'll plug that in. Let's do default value. Actually, let's change this to let's do like 0.6 or something, and then we're gonna do the same for this. So S and click, and let's call this shadow brightness. We might have to, brainstorm those names a bit, but we'll start with that. Let's give this a default value, something like 0.05. And then we're going to move on, but we'll circle back and kind of tune these values to show how this input is going to affect the brightness of all the values that are above 0.5, all the pixels above 0.5. And then this one similarly will affect our shadows. So it'll make shadows either brighter or darker. And actually, let me just go ahead and let's do this. Let's search for lighting, named reroutes, and we'll just plug this in directly just so we can see something in the output. Okay, so we have our dark ball there. Yeah, we have everything here. Diffuse, yeah, okay. So we'll see in a bit here, but we'll adjust these parameters, and then we'll see kind of how that affects our shadows in the lit areas. Okay, so let's save real quick, and then let's add a couple of comments just so we know what's going on. So for this area, this is, so if A is greater than B, that's our lit areas, right? Oops, adding a little bit more to my comment here. And then if A is less than B, that's going to be the dark areas. in this scene. And then we're going to use the multiply to tune our brightness. Okay. All right. Plenty of typos there. Let's drag that down. Okay. So that's essentially what's going on. We're going to use these two inputs. We're going to look at the values, and then for areas greater than 0.5, we're going to use this as our input. And for areas less than, we'll use this. Okay. All right, so this is this area. Let's add a comment around this portion. And we'll just call this let's do like lighting. So we're getting the brightness of our materials in the scene. Actually, pixel and bring it to grayscale. A bit verbose just so that we can kind of know what's going on and circle back to that. Clamp between 0 and 1, and then we use that something like that. Okay. All right. So that's the first piece of this material. So now we have I guess you'd call it a lighting buffer that allows us to look at the light and dark areas of our scene. And then we can handle those areas differently. So we need to go back to our main material node real quick. So let's click on this, or if you click off, you'll get the details for your material over here. So let's scroll down. Let's go down, down, down. Looking for, under post-process material, we want the blendable location. So by default, it's set to scene color after tone mapping. So if you hit this drop down, I'm working in 5.6. So in the past, there was a scene color before tone mapping option, and that's what you ideally would have used for a cell shading material. And you'll see a lot of tutorials that have that option selected. Unreal Engine recently changed some of the rendering pipeline on how things are handled, especially with like the rising of Lumen and all those things. So now things are a bit different. Now there's only the scene color after tone mapping, or you can replace the tone mapper and do some custom stuff in here if you want. But what I found is if you want to get similar results to some of the what you would have seen in like Unreal Engine 4 or early Unreal Engine 5, you can set this to scene color before depth of field, or even after. Either of these will give some similar results. There is some additional work, which is why we have these multipliers here, and then you'll see a couple other places where we have to add some additional logic, but this should give some similar results. So let's select that. And then now you see we have a nice like separation or band here. We have two regions, right? Two distinct regions. We have this bright area at the top and then the shaded area at the bottom. So you can kind of see where the light is coming in. And that's the foundation of this effect, right? Or this shader. Let's compile and save real quick. And let's jump back to our scene. And then if you zoom in, you can kind of see now we have a nice effect on a couple of the characters here. But when I have I have my lighting probe in here, and if you notice something, there's two things going on right now. So these characters that have, you know, some roughness on them, or let's call them, they have dielectric materials, so non-metal materials. They look great, right? We get our nice shadows, our nice two regions, looks kind of toony already. Same for our chamfer cube. We get the nice shadow or like line there. But if you notice on Manny, which I think has a metallic material, everything is dark, right? It's all black. Same for this guy, Murdoch from the Paragon assets. This one looks pretty good, right? But you kind of see there's some areas that are just completely blacked out, like on the gun here and on his gauntlet or arm here. So that's one issue that you can notice, and then the same on our lighting probe. So this first sphere is actually a chrome material, but it's completely blacked out. And then if you look at the sky is also completely black. So those are just a couple issues that we have right now. The other thing is, I mean, if this is the effect you want with the Skybox, that's okay, right? You can, if you're going to be in a dungeon setting, you don't need to account for this. But if you, and then of course, if you're doing more stylized design, you could, you know, add a custom Skybox that does things a little differently. But if you're using the default Skybox and things, you want to find a way to still use the one in your scene and not have it completely black like this. So let's look at how we can handle that. Let's go back to our material here. So we have our lighting handle. This is, again, this is all you need to get started with the basic shell shader. But there's more that can be done here. So let's do the next step. Let's go down here a little bit, and we're gonna let's copy another scene texture down here. This time we're gonna look at the scene texture depth. The scene depth is actually what it is, texture ID. So the second one down, we're gonna switch it to scene depth. And so this is basically telling us the depth of the pixel from the camera, the distance of that pixel from the camera, right? So when you're working with the Skybox essentially has an infinite scene depth. And so what we want to do is check to see what the scene depth is for the pixel. If it's very, very, very far away from our camera, then we can assume that that's part of the Skybox, and so we can just ignore that from our logic up here, right? So let's see what we need to do. So we're gonna divide, and then let's divide this by a very large number. Let's say like 100,000. Let me see. Yeah, 5 zeros. And then we'll do another desaturation. Not D and click, just right click, search for desaturation. Connect that. And then we'll do another if node. So I and click, and that'll go into our A. I'll drag this over just a little bit. Okay. And then, so let's check this. Let's set this to 1 by default. And the nice thing is, so everything in here honestly should be parameterized. I'm gonna leave this as a constant, but we really should go back. Actually, let's just make it a parameter just so that we can go back and modify things as we work in the material instance. So we'll call this our I'd say like a Skybox threshold or something. Did I spell that right? I did not. That's fine. We'll just leave it. Okay, so that'll go into B. We'll set that to 1 by default. Okay. And then if A is greater than B, we're going to just return our lighting buffer. Is what we want to do. So let's search for lighting. That'll be our rewrite node. We'll plug that in. And then if A is less than B, we're going to actually return our post-process input 0. And so this is a design choice. This is, again, there's other things you could do here. but I'm going to return post-process input 0. And basically, if you recall, this is just returning what it looks like before any post-process materials are being applied, or post-process effects. So this will be A is less than B. Oh, actually, I think I have that. Do I have that reversed? I do have that reversed. So we want this to be A is greater than B. Lighting on A is less than B. That's what we want to do. There we go. So if it, yeah, that looks correct now. Let's drag that over here. Okay. And then let's add another reroute node. Let's call this not a reroute, just a named reroute is what we want. Named. Yeah, there we go. Let's call this Skybox. There we go. And then we'll add a comment. Let's do Skybox color. So yeah, don't. Okay, so we're going to handle the Skybox differently. So this is what will happen with the Skybox instead of the standard lighting buffer that we have now. So we can handle this however we want. We could set up an additional logic to handle this differently, but let's see what this looks like first. And let's do this. We're gonna disconnect that. And we'll just plug Skybox in here. I need to add an additional node, name node or something here, but let's apply and save. And then let's take a look at their level. There we go. All right, so now you see our sky just looks normal, right? Just kind of the standard effect that you would have in your scene. But it's no longer black, so that's great. That's a good first step. Now, if you wanted to, again, have something more stylized or customized, you can do that here. Into your A is greater than B input here. And then we'll move on to the next step here, which will be handling these metallic materials. So if you look again, our metallics are just blacked out, right? So we want to handle those differently, or ideally you want to handle those differently. It's not a requirement again, but I prefer to have a actual color coming through. So let's look at how we can do that. Again, we're going to start with the scene texture. Put that there. And then in this case, before we build out the logic here, let's talk about what's actually going on with our metallics. So when you're working with a dielectric or non-metal material, the color that you're seeing is coming from the diffuse, right? The diffuse albedo color reflection that's coming off of this, or excuse me, coming off of this material over here, right? And so when we are looking over here, up here, we're comparing the post-process input, which is what's on screen currently for that pixel, to the diffuse color for that pixel. And so that works great for non-metals. But the issue is when you're working with a metal material, so metals don't actually have a diffuse color, right? Everything is actually coming from the specularity reflection of that material. And so when you have like gold or copper or whatever color, the color you're seeing, so that brown color or yellowish color or tint, is actually coming from the specular reflection of that material, not the diffuse. And so that's the issue we're getting right now. So we're dividing this by 0, or dividing these two, but we don't have an actual valid value here. And so essentially it's just gonna come out black, completely black. And so we could do something up here to handle that differently. if you wanted to, but what I think makes more sense is to add an additional buffer or logic in here to handle metallic materials, because you just want to handle those slightly different, right? So if a material, let me mention one more thing. Let's go back over here. So within Engine, so you can, within Unreal Engine with PBR, you can set a base color, right, for your metallic material. So you have your base color, and then you have your metallic input. So this could be set to 1 and still have a base color going in here. So it doesn't really make sense, right? Because again, it would be coming from the specular reflection, or the color would be coming from the specular reflection if it's a metallic. So what's actually going on with Unreal Engine is it's going to treat this base color differently depending on if this metallic value is set to 0 or 1. So if it's set to 0, it's going to, again, treat it like a diffuse or albedo color. But on the other hand, if it's set to 1, Unreal Engine is actually going to treat this base color as the specular reflection or tint. And then you can look at this in the actual like source code for the engine. You can see how it's going to handle this input depending on if it's a dielectric or a metal or non-metal material. So something interesting to note as you're working in Engine. And again, it doesn't really affect you because it's going to handle that under the hood. So you can still set a base color. So you can still get a gold or a bluish material or one that's completely chrome or whatever else. But something interesting to know about. Okay. Now, let's actually jump into our logic now. So we want to sample. So right now we're sampling scene depth. Let's change this to, I think we want post-process input 0. So what our scene looks like, again, before the post-processing effects have been applied. We're going to, let's right click and we're going to search for dot. So dot product, okay? And then we just want, let's do V and click. And that'll give us a vector parameter. This doesn't necessarily need to be parameterized actually, because this is really just going to be used as a constant. But what is it? 3 and click to get a vector? Yeah, we can do it as a constant or a parameter. I guess it's really up to you on how you want to handle this. So when you do this dot product, it's going to have a slightly different effect. So you could tune this to fit, to really adjust how you want that to look. So yeah, I think I will parameterize it. Let's do this. It's nice to have some of these things parameterized, and then you can tune them to get a really good understanding on how it's going to affect the final look or design. But if you're just kind of like basing it off of, building it by default in your base material, then you can add constants and circle back to it. But okay, let's set these, let's do like 0.3s on these. We're just going to give it a grayish color pretty much. Okay, so we'll do that. We're going to take another post-process or scene texture. And then this time, so before, again, we were looking at the diffuse color. In this case, we want to look at the specular color. And this is what's going to tell us or give us information about, the metallic, whether it's a metallic material or not. So let's do this. I think we want to do, we want to plug this in. Actually, no, we want this down here because this is for UVs. What I want to do is, I'm going to do another if. So the logic is pretty similar for all of these. So let's just do a metallic threshold and plug this into B, and we'll set this to 0.5 by default. So similar to our lighting buffer. Okay. And then, so if A is greater than B, we want to return the specular color instead of the diffuse color. And then if A is less than B, we're going to return, so I'm going to do this as a parameter, but really it can be a constant color. We'll do like metallic default color or something like that. And we're going to do 0.18. So it's going to give us a kind of a gray color. And we'll plug it to A is less than B. Okay. Let's delete this. And then, so we have a couple options of what we want to do. I'll just multiply it. Let's see what that looks like. Yeah, let's take another scene texture sample. Let's sample the lighting in this case, the base color for lighting. We'll kind of mix that in with whatever is coming through our if node. So we'll just multiply that. And now let's do a reroute node here, named reroute. Okay, we'll just call that metallic buffer. All right, so not too complex, right? So when you're working on materials, there's just so many nodes and or expressions that you can use, and it can be hard to find documentation on every single thing. So it takes time to get an idea on what the heck is going on. Watching lots of videos, digging a lot into what documentation is there, maybe looking at the source code some to get an idea. So it's a process, but it helps to have comments and look at the sample content from Epic, and that's always can set you down the good path. Okay, this is going to be our buffer for handling metallic materials. And we'll just make a quick note. So metals, don't have a diffuse color. Oops, I cannot spell. There we go. Okay, so we'll use our specular color instead. Okay. All right. So now we have, at this point, we have 3 different buffers, right? Or 3 different calculations that we have to determine what our pixel looks like, what type of pixel we have. And I keep saying pixel because I think this is an important thing to note when you're working in the material graph or working on a material. When we're working on this shader, we are basically, you can think of this as the logic to handle a single pixel on the screen. So we're looking at what that pixel looks like. We're sampling it. We are gonna, apply, change where its position or like the position of the color or texture on that pixel, the lighting, blah, blah, blah. So we're looking at that pixel, one pixel specifically. So this logic, when this shader runs, you can think of it as looking at a single pixel. And that helps you visualize or helps me at least make sense of what's going on in a better way, because it can be confusing just thinking like, oh, this is the entire screen, so how can our scene depth be looking at everything at once? And once this is running on the graphics card, it is essentially in parallel, right? So it's happening all at once, right? But if you think about it within just your graph, looking at one pixel, that starts to make a little more sense, because each time this runs, it's going to look at a single pixel. We're going to get its depth, and then we're going to say, okay, divide it, desaturate it. If that pixel is, the value we get from that pixel is greater than 1 or less than 1, then we're going to do something with that information. So we want to set its color to this or this, essentially. And anyway, so that's just another thing to note or understand about when you're working, or understand when you're working in the material editor. Okay, so now we have our metallic buffer. Let's look at how, right now we only have our Skybox logic and our lighting buffer going through. We need to incorporate this metallic buffer as well. So how do we want to do that? Let's nuke this. And then, let's see. Okay, so this one has lighting input here. Let's get our lighting, and then we'll get our metallic. Yeah. I probably should change these names to be consistent. So lighting buffer, skybox buffer, I guess, or something that is less confusing would be ideal. Okay, so we're gonna L click, and then we're gonna plug these into a lerp node, like so. And then our alpha is basically, so we have our, remember we have our metallic buffer. This is looking at the information for that pixel, but we want to check if that material is if the pixel is set to a metallic material or not. So what we need to do, I'm not going to copy, let's search again for a scene texture. And then if you expand this, there is a, where is it at? Metallic. There we go. And then our alpha needs to be clamped, right? See, oops, not a parameter, that's not what I want. Which means we want to use the saturate. It needs to be clamped between 0 and 1 for our alpha. So we'll take a saturate, and then we'll plug that into alpha. Okay? So if it's metallic, we'll return the metallic buffer. If it is not, if it's dielectric, then we'll return just the regular lighting buffer. Okay? And then from there, I think what we can do is, I probably should clean this up a little bit now that I think about it, because this is, I like to work from left to right, and this is going to plug into here, ideally. And then this will be our final output, which would go there. But yeah, I guess I can do this, right? I can, let's do another named reroute. Let's do, again, there's better ways to do this, but I'm just going to do it like this. And yeah, so I'll have our final output, and then we'll just plug in, let's see, let me just take this back here. I think that makes more sense. Let's pull this. And let's reorder this. I'll put our skybox at the bottom. Put our metallic buffer next. There we go. Okay. And then we'll do our skybox. I'll give me a little bit of room at the bottom. I'll drag this down there. Oops. Okay. And then this will just, oh yeah, into our is less than. And then we can delete this guy. And we'll just straighten that out a little bit. Okay. All right. And then basically we just need to plug this into here, right? I wonder if this will work. Let's try this. Does that work? Something like that. Probably what you should do is take these as like the minimal amount of logic, and then have a, you know, your lerp and another if statement that handles these all in one for your final output. That way it's less confusing. You don't have like, well, it seems like a circular reference, but or like confusion on where the logic is happening. But this is okay, I think. This will make sense. So I'm gonna drag this over here, just so we know what's going on. Okay. All right, so that is the foundation, right? That's basically everything. Now we have our lighting buffer. We have some logic to handle metallic materials, and then we also have some logic to handle our skybox. So let's go over to our material, or excuse me, to our scene. And now, if you look at the Manny character. And that looks much better, right? Before it was completely black, right? Now we have a color coming through. And then we also have kind of reflections, right? Which is cool. There's some work that could be done, right? Because if you look on the backs of these, right, we have a nice dark shadow. And this one's a bit much lighter. So we could do some additional work to handle that. But we do have, you know, the standard shadow on the floor. That looks fine. So, and then same thing over here, right? So these silver or chrome areas were completely blacked out. Now we actually get a color coming through, which looks good. Okay. And then our chrome ball is just gray now coming through for that specular color. Okay. So that's pretty good. This is, you could stop here if you wanted. I think the next thing I would do is if you wanted to have some Toon Outlines, you could also add some logic to handle that here. So I think that's the last thing I'll show, and then we can. There's other options where, if instead of you didn't want this to affect the entire scene, you could add some logic to use your scene or your custom depth. I think is what it is actually, and then if you are sampling just custom depth in your material, you can select different characters or objects in your scene, and if you search in the details, let's do custom depth. You have this under advanced, you have this option, excuse me, rendering advanced, you have this option called render custom depth pass. If you check that, then this information will be rendered in a custom buffer. Then you can sample information from that. And so if that object is being rendered in that buffer, then you can apply this post-process material to it, essentially. Yeah, I might throw that in after I do the tune, the outlines. Let's do the outlines first, because I think that'll be cool. So, let's come down here. And this one's going to be a bit different than the others. What do we want to do? So, we want to search for scene textile size. That's what we want. Okay. And then we'll do, so click an M, or M and click. We'll take 2 multiply nodes. And then we're going to create a parameter here. Let's call it outline pixel size. Plug that into B. This is going to plug into A. And then we're also going to plug this into A down here. And we'll do -1. Okay. And then we're going to take essentially the same logic here on both of these. Plug that in. And then we also want, so right click and we're going to search for screen position. And then we're going to plug that into B for both of these. Okay. And then we're going to search, or let's just copy this again. It makes it a little bit easier. I'm going to take 2 of these guys. And we'll just plug those in here. And we want to sample the post-process input for both of these. So we'll switch those, and then we'll need a desaturation. I guess I could have just done one and then copied it all at once, but I like to make things difficult, I guess. Let's do that. Okay, and then we want, if you right click, let's search for distance. And then we'll scroll down, and under utility is what we want. So distance, we'll plug those into A and B. Okay. And then just a couple more things. So we're going to need a parameter. Let's S and click, we'll do outline. Oops. outline edge threshold. And instead of an if, we're going to do something a little different. So we're going to right click and search for smooth step. Okay. And then we're going to plug this in. So this will be our value. Drag this up just a little bit. Our min we're going to leave at 0, and then our max we're going to set to this threshold value. Let's start with the value. Let's do like 0.2, I think is what I did previously when I was experimenting. And then we'll use, so what I like to do is if it's something that I want to experiment with or enable or disable, I like to have a switch parameter. So let's do the static switch param, and let's call it use Toon Outlines. Okay. So if true, we will return the outlines. We'll default the value to 0 or to false, excuse me. And then we will, let's just make this a static value here. So 0, right? Because if it's false, we'll just return nothing. And then we'll do another named rerouting node here. So we'll call this Toon Outlines. Okay. All right. Let's zoom out just a little bit so we can look at this logic and see what's going on. Let's set a default value for our outline pixel size. Let's do like 1.2 by default, or maybe we should just do 1 and see what that looks like, and then we'll adjust it in the material instance. Okay, so what's going on here? So if you Control Alt over scene textile size, basically this allows us to get an offset from a pixel, and so what we are trying to do is identify if a pixel is on the edge of an object or actor or character. And so this is essentially edge detection. So we're using the scene textile size, which basically gives us 1 over our screen resolution. So the nice thing about this is it's not reliant on the actual like measurements. So we don't have to account for different screen sizes. We'll just use this textile size and it'll automatically be 1 over our screen resolution. So we use that. We're gonna adjust the size of our pixel, or our range, I guess. So this isn't really pixel size, that's probably misleading. It's more like what the threshold is for how many pixels we want to account or consider to be an edge. So that will determine how thick the edges or the border is around each object. So we're going to do that. That'll adjust how much. The screen position will just give us the position of that pixel, or the pixel that we're looking at. And then, so what we're going to do is, this is going to give us a pixel, and we want to look at a pixel that's above and below and to the left and to the right? So all the way around our pixel. And so we're going to use that screen position to do that, and these multiplies. So the multiply by -1 will allow us to look on the other side, right? We're going to sample our post-process input, and then we're going to desaturate to get grayscale. And then we're going to use that as the input for our distance. So if this gives us our u and v, right? Basically the uv coordinates. If the distance is greater than this threshold, then we know that it's not an edge, right? It's far away, or something that's behind our character or far into the middle of our character's mesh. If it's kind of smaller within this threshold or below, then we know that we can consider that to be an edge, basically. So that's pretty much what's going on here. You can tune this to adjust like what's considered an edge, or how thick those edges are to get it like a specific look or feel. But that's what it boils down to. So let's select that, and let's put a comment. We'll call it Toon Outlines. do detect edges for objects in the scene. I'll just do that for now. Keep it short. Okay, so now we have that logic, and now we want to include that into our final output somewhere. So I think it would make sense to put here, right? So we have our Skybox. Maybe we want to do, let me think. So yeah, so we have our final output. We'll take our Toon Outlines. Let's do this. So take the Toon Outlines. Let's take a lerp node. And this is going to be our alpha value, I think is what we want to do. Okay, so this will be our alpha, value between 0 and 1. And then, so we'll use that to determine if something is an edge or not, basically. If it is an edge, or so if it's not an edge, then we can return this, right? Our Skybox information. So this might be a little misleading, but because this shouldn't be named Skybox really. Maybe this should be named Skybox and then we should break this out again. But anyways, we'll call this, so this will be what we return if it's not considered an edge. If it is an edge, then we want to return a specific color, right? We want to control, or we want to define a color that we want our edges to be, and then return that. So let's just, not a scalar value. We want a vector parameter, so v and click. Let's call this our outline color. Let's do that. And that'll be what we return here. And yeah, let's keep it, I'm gonna keep it black for now. I think that makes sense. Okay, and that'll plug into our final output. Oh, does this, yeah, this needs to be a constant value actually, I think. So let's do, because it needs to be a vector 3 or vector 4. This is, let's see if this works. I can't remember if it's a float 3 or float 4. Okay, so float 4, which that should work actually then. Our parameter should work if that's the case. That's odd. Okay, well, we'll do that. Ideally this would need to be a parameter because we want to be able to adjust that color in our material instance. But yeah, that's okay. We'll leave it like that for now. Let's see what that looks like for starters. Let's make sure we got our default values. So we got a default value of 1. Yeah, we got our threshold, 0.2. Yeah, I think that's fine actually. Okay. Let's apply and save. Let's see what we get in the final result here. Okay. Go back down here. So scene pixel multiply. We have our pixel size. That size should be okay by default. Oh, wait a second. Okay, here we go. So I have view screen position, but I have it coming out of pixel position here. That should actually be viewport UV. So we'll plug that into here. Let's see if that was the actual issue. Let's apply, and then we'll hit save. Okay, that is much better. So let's pull our material instance back in here. Let me just drag this down just a little bit. Okay. So since we parameterized all these things, we can go in and just go ahead and start adjusting these and see what they look like. So now we can make our lines nice and thick or somewhat thin, or we can disable them. Not with this, but with the use Toon Outlines, so we can disable those outlines, which is pretty cool. If you want outlines, so we can change the size of those outlines. And then, so this is the size and this is the threshold. So what is considered part of the outline. So if you notice, it affects the clouds too, which is pretty cool. So yeah, let's leave it something like that. So same thing for these metallic values. We can start to adjust these if you want. So if you notice, there we go. We can kind of adjust how the reflection looks. If we're just getting the specular color, or if we're gonna kind of treat things as more of a shadow. So it's starting to look kind of awesome, right? We can change the default color, which is cool. So that brightness of the shadows. Let's make it kind of dark. That looks kind of awesome. Yeah, maybe too much on the on the metallic threshold actually. I don't know, maybe I want a little more shadow like that. Yeah. And then yeah, it's kind of cool. So then it kind of looks different as you move around. Let's see what it looks like on here. Yeah, it's not terrible. Okay. And can we see our chrome? Yeah. Okay. What else can we change? So we can change our lighting buffer, so we can kind of adjust how the brightness, right? So this is the brightness that we can change for the light areas. So if you noticed, we have our two tones, right? So the top now, where the light was, is now black, which is interesting. So we can invert it, or we can make that super bright and washed out, right? But you probably want to keep it in a reasonable range. And then same thing, we have our shadow brightness, right? So we can actually make those white if we want to, or make them completely black. But I think a nice kind of gray color to give some soft shadows looks good. And then the same thing for the skybox. So we can, yeah, give us some shadowing there, which is kind of cool, or like brighter light. What happens if I raise this way up? Yeah, it probably just brings us back down to black, right? But we can use this to handle it differently if we want to. But I think I like it. Let's just leave it at 1 for now. It's okay. Okay, so that about does it for the cell shading material now. So now we have some basic settings that we can use to control our shader. And we can apply outlines or not. Let's go back just to review. So we created a material instance of this, but what we have is our lighting buffer up here. So this is just basically gives us two tones, right? Our light area and our dark area for shadows. Then we have some logic to handle metallic materials. We have some logic to handle our skybox. And then the last thing we added was some logic to handle our Toon Outlines. Okay, so let's stop there. This got pretty much longer than I wanted it to be, but I wanted to give some in-depth information on how things are kind of working and what the logic's actually doing. So hopefully this is helpful. Let me know if you have any questions or you want to dig into this some more.